In the previous lesson, we explored how to find the number of protons or electrons for any element on the periodic table, given the information that's on the element square on the periodic table. To be specific, we learned that the atomic number at the top of the periodic table was the number of protons, and consequently it was also the number of electrons for an atom of that element. But there's one part of an atom that we haven't learned how to identify from the periodic table yet, and that is neutrons. In this lesson, we're going to explore how you can find the number of neutrons of an atom of an element, given the information on the periodic table, or maybe when you're given additional information other than just what's on the periodic table. To start, once again, let's consider what those numbers on the periodic table squares are. First off, the atomic number, which is usually at the top of the element square, gives you the number of protons in any atom of any element on the periodic table. That number is firmly fixed because that number of protons determines what type of atom it is. So boron atoms have to have 5 protons in their nucleus. The bottom number, remember, is the average atomic mass. That number gives us the average mass of all of the isotopes of that element that are commonly found in nature. So the average atomic mass of boron is 10.81, a decimal number, because there are 2 common isotopes of boron in nature, one of them with a mass of 11 and one of them with a mass of 10. To understand this further, let's take a look at those 2 boron atoms. Here's boron 11. You can see that there are 5 protons and 6 neutrons in its nucleus. And here's boron 10 with 5 protons and 5 neutrons. Boron 11 accounts for 80% of all boron, and boron 10 accounts for 20%. So that's why the average atomic mass is somewhere closer to 11 than it is close to 10. But the number 10.81 is not terribly useful when we're trying to find the number of neutrons, because you can't have a decimal place number of neutrons. It has to be a whole number. Just like in boron 11, there are a total of 6 neutrons, not 5.8, and in boron 10, there's a total of 5 neutrons, not 5.2. So because there has to be a whole number of neutrons, we have to figure out a mass number that is a whole number. And to make the average atomic mass into a whole number is very simple. You just take that average atomic mass number and you round it off, because the actual mass of an atom has to be a whole number, because it's the sum of protons and neutrons, and you can't have a decimal place amount of protons and neutrons. So we're going to take that 10.81 and we're going to round it up to 11. Once we do that, it is no longer the average atomic mass, but it is an atomic mass number. And by rounding it off to the nearest whole number, you can round it up or you can round it down depending on where the nearest whole number is. By rounding it off to the nearest whole number, we ensure that that number represents the most common isotope of that element in nature. So because boron 11 makes up 80% of all boron in nature, when I round it up to 11, I'm rounding it to the most common isotope. All right, so I just want you to understand, all I did was I rounded the atomic mass number to a whole number so I can actually find a whole number amount of neutrons. Now, how do I use this information to find the number of neutrons? It's actually quite simple. You see, the atomic mass number is simply the total mass of all of the protons and neutrons in the atom. It's the total mass of the atom. And remember, protons and neutrons are the only thing that give the atom mass, and because protons and neutrons have the same mass, they each add a mass of 1 to the atom. So if I take that total amount of protons and neutrons and subtract out the number of protons, what am I left with? Just the number of neutrons. Now, do I have a number that gives me the total mass of protons and neutrons? Yes, I do. That's what the atomic mass number is. And in this case, I got that atomic mass number by rounding off 10.81 to the nearest whole number. Do I have the number of protons of boron? Remember, the number of protons is really easy to find. It's just the atomic number. So here's how you find the number of neutrons. You simply take the atomic mass number, and one way to do that is to round off the average atomic mass to the nearest whole number, and then subtract from that mass number, which is the total mass of the atom, subtract out the number of protons. And when you subtract out the mass of the protons, you're left with the mass of the neutrons, which is the same as the number of neutrons. Let's take a look at what the number of neutrons would be for boron. I would have to take the total mass of the atom, which is 11 from the rounded average atomic mass, subtract from that the atomic number, which is the number of protons, and because I have 11 total protons and neutrons, subtracting 5 protons gives me 6 total neutrons in an atom of boron. Now, there's another way that sometimes you need to find the number of neutrons, because honestly, boron isn't just boron 11 in nature. Sometimes you are dealing with boron 10. So sometimes, instead of just being asked to find the atomic mass of an element on the periodic table, sometimes you're given the atomic mass. You're given something that says boron 10. You're dealing with boron that has an atomic mass of 10. If you are given an atomic mass after the element name, you actually have to use that atomic mass. You just use the given atomic mass after the element. So boron 10 refers to boron that has an atomic mass of 10. We're not going to go and round from the periodic table because we know we're dealing with boron 10. Now, to find the number of neutrons in an element like this is really easy. We don't have to round anything on the periodic table. If the atomic mass is given, we just plug in that atomic mass, 10 total protons and neutrons, subtract from it the number of protons. We still have to attract the atomic number, 5, and we have the total number of neutrons. It has 5 neutrons as well. That's how you use the atomic mass to find the number of neutrons. You need to take the total atomic mass and subtract the number of protons. Let's do another practice example of each of these two scenarios where, number one, you're just asked to find the atomic mass given the information on the periodic table, and then number two, when you're given the atomic mass and you have to find the number of neutrons. We're going to use a different element for this, a radioactive element known as thorium. Now, if you were asked to find the atomic mass of thorium and not given any other information, just what is the atomic mass of thorium, you would have to go to the square for thorium on the periodic table, look at the information that's given, find an atomic mass number, not the average atomic mass. So we'd have to round that off. And when we round off 232.0318, we get just 232. There's 232 total protons and neutrons making up the mass of thorium. Then we have to subtract the number of protons from that total. That means we have to subtract 90 protons from the atomic number of thorium. That should give us the number of neutrons. 232 minus 90 is 142 neutrons. However, if we are given an atomic mass for thorium, because thorium comes in many different isotopes, one of them being thorium-228, then we don't even have to use the rounded average atomic mass from the periodic table. We would just plug the atomic mass that we know that we're dealing with into the equation. So we have 228 total protons and neutrons. We would subtract the atomic number once again, 90 protons, to get our number of neutrons. So to recap, to find the number of neutrons of any element on the periodic table, you take the atomic mass number and subtract the number of protons. The atomic mass number may be given in one of two ways. You may have to round off the average atomic mass on the periodic table, or maybe you're just given the atomic mass number. Either way, you can use the atomic mass number, subtract the number of protons from the atomic number, and that gives you the number of neutrons.